This section is a mounting systems overview where we're going to start to look at the different mounting and racking structures that are available in the market and start to discuss some of the considerations for choosing one over another. First thing we're going to look at is selecting our location for the array. And the location is going to be very site specific based on the needs of the customer, the site itself, and surrounding things like weather conditions, shade, distances, things that we all have to think about when we design and select our equipment. We need to decide right away, is this going to go on the roof of a building or is this going to be a ground-mounted system? Those are our two primary choices, and then we have a lot of options based on the type of roof, the location of the ground-mounted array, the size of the system will all be factors in our location selection. The reason why this matters and impacts our system designs is there's a number of different considerations for selecting the array location. Cost can be a big variable. Oftentimes, roof mounts are cheaper than a ground mount, but that's not always the case. It depends on the type of structure and a lot of considerations that have to do with the building itself and the location that it could go on the ground. And those are things we'll look at and consider. How much space do we have? Which will be how big is our roof? How large of a solar array do we really need? What sort of sunlight access do we have? Do we have a lot of shade? Or are we in an open field? What are our options for making sure that we put the array in a location that has the best production available? We also need to think about electrical and building codes. Do we have codes based on our either electrical standards, city, county, country, municipality decisions that will affect where we can or cannot put the solar array, and that might dictate a certain location. And then access to existing electrical infrastructure. If we put it on the roof, how do we get the electrical output of the array to the main service panel or service equipment for the building? If we put it on the ground, how far away is that ground mount from our point of interconnection to the electrical infrastructure? So some of the beginning considerations that we have to think about when we do select an option and what might affect the costing of my system. When we go in to start to look at different options, the first one here is a fixed tilt ground mount array. And so what we mean by that is it's obviously on the ground and it's attached to the earth, and then it's fixed in place, means it's not moving or tilt adjustable. We've set this design, and that design is set for the year based on our location, our latitude, our production analysis numbers, and our applications. And so fixed tilt, we're never going to move it. We're going to build it in place. That tilt angle will be based in the design from the manufacturer and in collaboration with the contractor and the site owner to determine the best spot. These can be small or large depending on what applications we have. So fixed tilt ground mounts can be really kind of any size or possible location. Tracking ground mounts. So this is what we call a tracker. So a tracker means we have a moving mechanical system. And so we're going to have a motor that's going to move the array to optimize the peak performance at all times. Most trackers these days are used for large-scale ground mounts for utility applications. And so we can select trackers if that's the right thing for our situation and do the cost analysis to determine whether a tracking mount system may be better or worse than a fixed ground mount array based on our location. We also have, or we could build pole mounts. Pole mounts usually means we have a center pole, usually a singular pole, and that is going to be set in a big concrete block. And then we can build small to mid-size solar arrays on that. Pole mounts have a better tilt adjustability, allow some versatility, and often some more height for the array if that's something that's needed. Things like carports are very common in cities and in the built environment. Carports are a great way to have an elevated ground mount. And so really it's the same concept as our fixed tilt ground mount. Carports are going to be a fixed tilt elevated array that gives us a place to use parking lots and covered areas with really two different capabilities. So we can generate electricity and we can park a vehicle or store equipment and have that underspace by having an elevated array like a carport structure. When we get into roof mounts, we usually have two different kind of primary categories, what we call a steep slope roof. Steep slope really means is water going to run off the roof at a normal rate. And steep slope roofs come with a lot of different roof types that are available. So we'll talk more in later sections about what roof types are common and how to make attachments to those roof types. So steep slope roofs are very common for a lot of residential applications in certain parts of the world. Low slope roofs mean that it is a low angle, and often people would say this is a flat roof, but technically no roof is flat because we need to drain water off that roof. Low slope roofs are going to be common on residential applications in certain parts of the world, and then also very common on a lot of large commercial building applications. And so we're going to have different mounting structures based on steep slope and low slope roof selections. Things we want to think about with really all of our mounting systems is what is the site-specific data that we need to gather? What information do we need to collect to make the right decision? And what sort of considerations? Things like, are we in a location with snow? Does that provide an additional load to the building and to the solar array that we need to consider? If we're not in a snowy location, what are the wind loads? Do we have big storms, hurricanes, typhoons, things that we have to consider? And what's that wind speed and wind exposure? The mounting structure systems, the racking manufacturers will help us with this design to make sure that we meet all the wind loads of our location. Do we live in a place that has a seismic load consideration? So do we have earthquakes and have to consider that the building might move? And how do we make sure that the array is going to be fixed and meet our seismic load requirements if they exist in a certain area? And then another big one, of course, is always going to be drainage. How do we make sure we're allowing water to move off of a roof? If it's a low slope or flat looking roof, we need to make sure that water has a pathway to drain. We're not creating a dam on the rooftop to stop water movement. Anything that's steeper slope, we usually get a better drainage because of the angle of the roof, but we still need to make sure that the array we install doesn't impede the drainage or the structure of the buildings in any way. Also, the drainage can be a big issue when we deal with large ground mount arrays to make sure that we control erosion and any concerns that could come with how water is going to move across the site. And on big utility scale sites, that's a big deal to make sure we have proper drainage, and that comes as really part of our engineering process for big systems. And just considering in the photo here, just looking at things like these sorts of ballast mount systems, and roofs all have drains. And so not only do we need to be clear of obstacles, but we need to make sure that we're not putting things in a location where it's going to cause a problem for our system in the future or the building maintenance in the future.